We got no more questions for today. You have another one? Remember, the goal is just to get 100 on your homework. All right. Juneteenth is no school. You're right. That's like next week, Tuesday, I think. No, next week, Wednesday. Excuse me. I'm sorry. Yeah. Found it or no? All right. So let's start off with a little blast from the past, real quick. Nothing complicated, just something quick. So help me out. I want you to evaluate this and tell me what to do. Mm-hmm. Mm-hmm. Good. And what's 5 times -1? Okay. What's that answer? 11? No. -9, right? Good. All right. Any questions on that? Good. A little bit harder. A little bit harder. Let's see. Little blast from the past. How about this? Oh, no, it's like saying you owe me $5 and you owe me 4 more. So now you owe me $9. Like that. Yeah. So -9. So how about this one? I want you to evaluate 3x minus 2y when x is equal to 4 and y is equal to -3. Okay. Uh-huh. Mm-hmm. Mm-hmm. Good. All right, do the math for me real quick. Uh-huh. Not minus. So negative times a negative is a positive, and 2 times 3 is 6, all right? And 12 plus 6? 18, good. Questions on that? We good? All right. We're gonna take this up a notch. No, you can leave after that. Wednesday, I'll give y'all a review. So help me out with this now. I want to solve for y. How do I do this? Right. Okay, good. I'm gonna subtract 8 on both sides. So I did to one side, do to the other. So now I have -3y is equal to, what's that, 12? Okay, what do I do after that? Divide by -3, right? What I do to one side, I do to the other. So now I have y is equal to -4. Very good. That's my answer. Questions on that? You good? Awesome. All right. So let's look at, huh? Right. Yes, because a positive divided by a negative is a negative. Yeah. And vice versa. Negative divided by positive is negative also. I just don't have time to teach you how to do it, so go to tutoring for that. Mm, maybe Thursday midnight. That don't mean don't do it though. All right. All right, so let's look at what we're gonna look at for today, right? We're gonna graph a linear equation by plotting points. Yay. So, yeah, that's up, right? You know that, little Rene Descartes and all that. Yeah, that's smooth stuff right there. So there are several methods that can be used to graph a linear equation. The first method we will use is called plotting points, or the point plotting method. Yippee. We find 3 points whose coordinates are solutions to the equation and then plot them in a rectangular coordinate system. By connecting these points in a line, we have the graph of the linear equation. Yay. This is going to be fun. So let's look at this, right? How to graph a linear equation by plotting points. All right, between me and you, I'm about to show y'all the sauce right now for Math 30. All right, this is like the whole Math 30 summed up in like one lesson right now. All right. Math 30 is a whole class of like tricks around this. But if you do this one method for every question in Math 30, you'll always get it right. All right. So here we go. How to graph a linear equation by plotting points, right? Nah. Way different. Way different. Way easier. Way easier. So the secret, make a table of values. Right? What's a table of values? I'm gonna have some X points right here. I'm gonna have some Y points, right? So for X, I'm gonna give you my favorite numbers to use, right? This is my favorite right here. -2, -1, 0, 1, and 2. Right? If this was Math 30, these are the numbers that I'm using. Now, in actuality, you don't need this many points to plot a graph, right? 2 is good enough, right? Three if you want to be sure, but 2 is good enough, right? But for me, right, my favorite are these 5 numbers. This is what I use in Math 30. I use the same process again and again and again, right? Kind of boring, but it works for multiple classes, right? So now you see how I have I'm just gonna look at the first one right here, right? We have this -2, right? All right, what I'm gonna do is I'm going to plug that into the formula up here. So we have y is equal to 2, but instead of the x, I'm gonna plug in what? -2 plus 1. We're gonna do the math on that. 2 times -2, that's what? -4 plus 1. So this is what? -3. Did I lose anybody? We're good? So that's why I'm gonna put it over here right now. That's the y value, -3. Boom. Right? I'm gonna do the same thing with the next one. All right, let's try it out. So I'm gonna have y. I have the 2, but instead of the x, I'm gonna plug in -1, right? Plus 1. Now 2 times -1, what's that? -2 plus 1. So this is what? -1. I'm gonna write that in right here, -1. Did I lose anybody? Good? A little bit lost? Gotcha. All right. So what I'm doing is you see the, let me erase this real quick. You see the numbers in this column, right? Which I personally chose. These are my favorite numbers. All right. You could choose whatever numbers you want. If you want to work with 1,000,000 or you want to work with 200, go ahead. I like these basic numbers, right? Your choice. I made these up. You're just taking these numbers and you plug it into the equation. That's all. All right. And as I said, you do not need to do so many, right? I just like these 5 numbers. You could literally get away with doing 2 of these and get it right. 3 to be sure. Uh-huh. No, it's just gonna ask you to graph it. But we plot the point so that we know how to graph it. Yeah, that's what that is. Hmm? So I'm just plugging in the number. 2 times 0, you already know. 0 plus 1, so that's 1. and so on and so forth, right? I'm gonna have y is equal to 2 times 1 plus 1. That's gonna be 2 plus 1, which is 3. Write that in. And then finally, y is equal to 2 times 2 plus 1. That's 4 plus 1. That's 5. And then boom, 5. Okay. Phew. That was the hard part. So this right here, this is my table of values, right? Just showing you guys how to do it. You can choose whichever x values you want to plug in, right, to get out your y values. I'm just giving you my favorite, which is -2, -1, 0, 1, and 2, right? After that, you just have to plot them on a graph and then connect the dots. That's it, right? I got you. So look, here goes your axes right here, right? The horizontal axis is the x-axis. The vertical axis is the y-axis. Right? Vertical means up and down. Horizontal, side side. I made it up. I chose that. Yeah, you could choose whatever numbers you want. Yeah, no matter what. Yeah, no matter how far away it is and all that. You know, I just keep it simple because I don't know if I told y'all this, but I don't know my timetables. I know my ones and my twos, so you know. So basically, we're just gonna plot this, right? Our first points, let me circle it. Our first point is -2, -3, right? So here's how we plot that, right? I'm gonna come down here. Right, let me do something real quick. Need a good color. What's a good color? I'm gonna do orange. Do orange. All right, just want to count some numbers out here. We have 1, 2, 3, -1, -2, -3, -1, -2, -3, 1, 2, 3. All right. So this is our coordinate plane right here, right? My first point I said was what? -2, -3, right? So what do? I come across on the x-axis to where -2 is. -2 is right here, right? And then I'm gonna go down, right, to the y-axis where the 3 is, right? So bam, this is where they meet, right? So this is my point, right? That's the point, -2, comma, -3, right? It's where they intersect that, right? And you always do the x first and then the y, right? X first and then the y. Let's take a look at another one, right? I have -1, -1, right? Is that right? -1? Yeah, how about that? That's right. So we go to -1, we go to -1, which is right here. I have a lot of ink right there, so I'm just gonna leave it as that, right? -1, -1. Right? Notice how I'm labeling each point, right? That's what we want you to do. I have 0 and 1, so 0 and 1 is right here. So this would be 0, comma 1. Wait, no, it's not. Let me try that one again. 0 is the origin, right? As the center. Go up 1, right? That's 0, 1. Sorry about that. Little mistake. Go ahead. Yeah. So I'm just gonna do that over here, 0, comma 1. All right, next we have what? 1, comma 3. All right, so we got, let me see. I'm gonna come across here to where the 1 is, go up to the 3. 1, comma 3. Again, you don't need all these dots. I'm just kind of overkilling it for you guys in the lesson, right? Just so that you can see. All you need is 2, 3 to be sure. All right. After you plot all those points, you just connect the dots in a line. I do not have a ruler, so I'm just kind of eyeballing it, you know. I didn't plot the last point, 2, comma 5, because as you can see, my axis like ends at 3, and 5 is like somewhere else, right? But it's on that line, right? It's on that line. Right. It would align with that line right there. And that's it. That's how you plot points, right? You make a table of values, connect the dots, and that's it. Right? So congratulations, y'all all ready for calculus now.
So it doesn't matter like either
Mhm.
side, you can just make it different both sides. Just
Yeah.
one.
Yeah. You could and for this particular lesson, again, you can totally do this with like two or three numbers. You don't need five or six, right? I'm just giving you my favorite. These are my favorite. The zero is my most favorite. That's the easiest. All right. I don't know if anybody wants to take a picture. I'll make it smaller. I think that's about it. Actually, you know what? Let me just come down here like that. There you go. Huh? Awesome. Awesome. So yeah, in Math 30, what they're gonna try and do is get you to draw graphs kind of like this without having to do the table of values, you know? But the table of values will always work. Always.
Well, they don't like allow you to use it.
No, you could use it, yeah. But it's up to you what you want to do. I use table of values in calculus. Like who got time for all that complicated stuff? Just plug in the numbers and that's it. So we good? I can move on? All right. All right, go ahead. By the way, when you use your calculator, this is how the calculator does it as well. The same process. So it's all related. All right, you guys try. It's all good. And you could keep it simple. 3 points, connect the dots. That's it. We good. Mhm. Yeah, it's no problem. Whatever you want. In any number you want to start by. Yeah. Let me ask y'all, since y'all kind of know me a little bit, right? If I had to pick 3 points for this, what 3 points you think I'm gonna pick? All right, you got two of them. 0 and 1. And what's the other one? No. -1. -1. Just do three. You can do as many as you want. Just do three. 1, 2, 3. Yeah, 1, 2, 3 is fine. See, for me, right? Like, be honest with you. I might not know my timetables, but I know my 0, my 1 timetables real well. Like real strong. So that's why I use those numbers. While this is going on, let me see if I could push another video to YouTube real quick. Mm, No problem. Mm-hmm.
Prefer to be called one.
Huh?
Would you prefer to be called one?
You call me Chris. It's all good.
Alright, what do you think? You can upload the rest of the videos.
I'm trying to do it right now.
Oh, appreciate it. Don't worry.
It's all good. That's not easy though. Like it takes a minute to do.
This,
Mhm.
like this.
See, looks good. Yeah. All right, let's go over this. It's gonna take a whole half an hour. Well, not this question, I mean like the next video. Anyway, I want to graph the equation by plotting the points, right? So I have y is equal to 2x minus 3. Y'all already know, table of values. And I already told you guys what I'm gonna do. -1, 0, and 1. Because that's my strongest timetables, right? Over here, I'm gonna have y is equal to 2 times -1 minus 3. That's gonna be what? -2 minus 3, so that's -5. Boom, -5. Over here, it's the hardest one of all, right? 2 times 0 minus 3. What's 2 times 0 again? 0 minus 3, -3. All right. That one was challenging, right? Let's try the last one, right? Y is equal to 2 times 1 minus 3. What's 2 times 1? 2 minus 3, what's that? -1, right? Boom, right? After we get those three numbers right there, I mean 3 points, excuse me, right? We're gonna plot them, right? We're gonna plot them. So I'm gonna have my axis like this. I see that we have to go out to 5, so I'm gonna try and go by 5. Let me get my orange out real quick. So I have 1, I have 2, I have 3, 4, I have 5. 1, 2, 3, 4, somewhere up here, 5. All right. I didn't even label my axis and nobody told me nothing. And that's my Y, that's my X, right? All right, let's keep going. This is -1, -2, -3, -4. Whoops. Try that again. -5, right? Extend that out just a little bit, make it look pretty. All right. And then back at it, -1, -2, -3, -4, and -5, right? You know what? These would look nicer on the other side. In my opinion, right? Your choice. -2, -3, -4, -5. That way it's not confusing, you know, with the dashes that are there. Your choice. Anyway, get my pink out. So my first point is what? -1 comma -5, right? So I come across a -1, go down to where -5 is. That point should be somewhere like right here. This is -1 comma -5. What's my next point? My next point is 0 comma -3. Come across the 0, go down, -3 right here. That's 0 comma -3, right? And my last point is 1 comma -1, going across the 1, -1 right here. This is 1 comma -1. And then you could keep going if you want to, but 3 is enough. Connect the dots. And that's the graph. Questions on this? Everybody get that? Go ahead. Hmm? Yeah, three will definitely verify that you have a good line. No? And the numbers that you plug in is totally up to you. Huh? That's fine. Yeah, that'll work too. Yeah, that's not a problem at all.
Well, I'm sure that one. Yeah. I don't want to make it. I should add this.
Right,
should-
exactly. So -4 minus 3 is,
Oh, okay.
yeah,
Oh.
it's -7.
Oh, I was mixing up the sign, man.
Yeah, got you. Yeah, it's all good.
Overcomplicated. I thought you were supposed to like take x 2 times or whatever, like 2 of x.
2 of x? Like
Yeah,
what?
like y equals 2x, whatever x is equal to.
Yeah.
Twice.
Like basically what I'm doing is I'm making up numbers for x and I'm just getting out a y value And then from that, I'm able to plot the points and do the graph.
But you're also making up the first y, right? So that you can multiply it.
No, I don't make up the y value, just the x's.
So where do you get the 2 from?
Which two? It's an equation, 2x minus 3.
Oh, you just, oh.
Yeah, but the value for x, I'm making that up.
Yeah. Divided it backwards. I put, instead of, so doing I put 2 Y's, so then when I plotted it, it came up. Yeah, I forgot to do X. This is supposed to be X.
Exactly. Yeah.
All this is
Well,
supposed to
no. The answer is y. This is right. The answer is y. These are the x's here. You're plugging in.
Right, so when I came down and put it on the X and Y,
Yeah.
I think
So, like, for example, this should be 2. Hold on. 2 times 2 is 4. 4 minus 3 is what?
4 minus 3 is 1.
So that should be 2 comma 1. Of course, 2 goes 1.
Oh,
Yeah.
that was this one.
Yeah. And this one, 2 times 1 is 2, and 2 minus 3 is.
2 minus 3 is negative.
Right, so that should be negative.
Okay.
Just plug it in. All right, so any other questions on this? Or we feel like we get it? We're just making up some numbers for x, plugging them in, getting a y value out, and we're plotting the points on a graph. That's it. In statistics, this gets a little bit more challenging. Worth it though. Nice class, statistics.
You do recklessness too?
Yeah. Now I could feel somebody in the back was like, yo, could you just write the notes for me? Cause like, I'm not getting it. I got you, right? So the steps to take when graphing a linear equation by plotting the points are summarized here. So I got you. Give you a little how-to, right? There you go. Boom. So how to graph a linear equation by plotting points. Step 1, find 3 points whose coordinates are solutions to the equation. Make up an x value. Organize them in a table. Step 2, plot the points in a rectangular coordinate system. Check that the points line up. If they do not, carefully check your work. And step 3, draw a line through the 3 points, extend the line to fill the grid to put arrows on both ends of the line, right? So you notice how my line just has those arrows at the end, right? That means that it's just keeps going, right? And that's it. That's your notes. Of course, with all notes is gonna come commentary. So here's your commentary. All right. So it is true that it only takes 2 points to determine a line, but it is good habit to use 3 points. If you only plot 2 points and one of them is incorrect, you can still draw a line, but it will not represent the solution to the equation. It will be the wrong line, right? So again, if you use 3 points and one is incorrect, the points will not line up. This tells you that something is wrong and you need to check your work. So look at the differences between these illustrations. So you see at A, right? I have 3 points. They all fall on the line, so I know that I did everything right. But you see how B is kind of like, for lack of a better term, scattered, right? So something went wrong there. One of the points or 2 of the points that I did the math on didn't work out so great. So I have to look back at them and try it again. Right, it should be a straight line. So when an equation includes a fraction as the coefficient of x, we can still substitute any number for x, but the arithmetic is easier if we make good choices for the values of x. This way, we can avoid fractional error answers, which are hard to graph precisely, right? So basically what they're trying to tell you here is be strategic in what you choose, right? I choose 0 and 1 because that's the easiest to multiply by, right? Sometimes you might have a fraction, right? Like let's say, I'm just gonna make up something real quick. Let's say I have y is equal to 2 over 3x plus 1. Just keeping it simple, right? If I wanted to choose an x value for here, right? Obviously, you know I'm going to choose 0. You already know, right? But another x value that I could choose that would be really nice here would be 3 over 2. Right? I choose the inverse of it because what happens when I multiply that by 3 over 2? What does it become? Huh? A whole. But what whole in particular? Becomes 1, right? Because you remember 2 over 3 times 3 over 2, that's just 6 over 6, that's 1, right? So if you multiply it by the flip, you'll just get 1, and 1 plus 1, you know, that's 2, boom, right? What's another nice number that we can multiply this by? How about the negative inverse? Negative 3 over 2. The same thing is going to happen, right? It's just that it's going to be negative 1, and negative 1 plus positive 1 is what? That's 0. All right? Just some suggestions. You know, be strategic in the numbers that you choose. All right? And when you're dealing with fractions, you know, like I'm not expecting the sun, the moon, and the stars. You know, like I get it. The number is in between 2 and 3. I mean, I don't need to know that it's just a little bit closer to 2 than like cool. You know, you get the idea. If it was the computer, I want accuracy. But with us, you know, we have room for error. So let's try this out. Let's say I want to graph this equation here, right? I'm gonna keep it simple. I'm just gonna choose a couple of numbers, right? Make my table of values. So tell me, what should I choose? 0. Okay, what else? 2. Okay, I like that. What else? -2. All right, I like those. Let's plug that in, right? If I plug in 0, you already know that's going to be 3. If I plug in 2, right? Well, let me show you why it is. Hold on. This is 1 over 2 times 0 plus 3. This is 0 plus 3, so that's just 3, right? If I plug in 2, remember that's like 2 over 1 plus 3, so that's going to become what? 1 plus 3, which is 4. And if I plug in -2, it's like -2 over 1 plus 3. What does that become? That becomes -1 plus 3, which is +2. Did I lose anybody? Any questions on that? I could. Yeah, I could do that too. Yeah. Mm-hmm. Yeah, that works as well. Huh? Yeah. Yeah, on there. Yeah, it's the same thing. 1 plus 3 is 4. My fault. I'm sorry. That was a funny looking 4. I'm sorry about that. There we go. All right, same game as before, right? I'm gonna have my axis here. You already know that's my X, that's my Y. I'm gonna go out to 4. 1, 2, 3, 4. I'm using the same color because I feel like we get this by now, but let me know if somebody here is not understanding. And then that's 1, that's 2, that's 3, oops, -1, -2, -3, -4, 1, 2, 3, and 4. And over here, what do I have? I'm gonna do this in pink. So I have 0, 3, right? So I come across to the 0 in the center, go up to 3, right here. Right? That's 0, 3. I have 2, 4, right? Come across to 2, go up to 4. It's right here. That's 2, 4. And then I have what? I have -2. I come up to 2. That's right here. There's -2. Oops. That's -2, 2. And then what do we do after that? Just connect the dots. I need a nice color, nice color. Let's do purple. Right? Just connect the dots and then that's it. Yeah, on both ends. Any other questions on that? So lesson here, just be strategic in what you choose. That's all. And no, you're not limited to those numbers. You can choose whatever you want. I'm just trying to make your lives easier. That's all.
That's how I'm supposed to do.
It's -2. That's negative. Okay, 0, -2. This is negative. No, you're right. You're right. You're right. Yeah, that's right. And you just plot the points and then.
I just gotta do it.
Yeah. All right. So that being said, you guys try. Same thing, make a table of values, plot the points, draw the graph. Simple, simple, simple. All right, class 2 is up. Mm-hmm. Mm-hmm. Inverse it. Get rid of the fraction. That's the wise decision. If possible, get rid of the fraction. All right, I'm coming back. That's interesting. You lie. I could minimize that? What? Wait. Hold on. 1 second. I just got excited for a second. 1 second. Hold on. Nah, I can't do it. Let me try. Let me try something. Let me try something. Nope. That didn't work. All right. Got hyped for no reason. All right. Anyway, I want to graph this equation, right? Y is equals to 1/3 x minus 1. The hard part is the table of values. What do we think? 0. I like that. What else? Huh? -1? Okay. It's a little bit hard though. Ugh. All right. What's gonna happen? All right. And what else? One more. 3/1. Okay. So let's do that, right? So I'm gonna have y is equal to 1/3 times 0 minus 1. And we already know that's gonna be what? 0 minus 1, -1. Then we're gonna have y is equal to 1/3 times -1 minus 1, which is gonna be what? -1/3 minus 1, which you know is -1/3 minus 1/1. And in order for me to subtract, I gotta have the same denominator. This y'all classmate, by the way, this ain't me. So this is -1 minus 3/3, which is -4/3. And then last one, we have y is equal to 1/3 times 3/1 minus 1, which you already know. right? That's gonna cancel out. That's gonna be 1 minus 1, which is 0. Yippee, -4/3, right? That's the thing, right? So we know that 4/3, it contains a whole, right? So it's definitely bigger than 1, but it ain't bigger than 2, right? So you know that's gonna be between 1 and 2. So like that's how you plot it, basically. Mhm. Between 1 and 2.
Except for all the brackets.
You'd have to do them out, change them into mixed numbers to see. Sometimes a fraction can be a little bit larger. It could have like 3 holes and be in between, like say 3 and 4. That's possible as well. Yeah. Yeah. It depends on the fraction itself. Yeah. So this one goes out to, I'm gonna go to 3 on this. Nothing crazy. So I'm gonna do 1, 2, 3, -1, -2. Hold on 1 second. -3, -1, -2, -3, 1, 2, 3. Let me just extend that out a little bit. All right. Just scroll up real quick. So I have 0, -1. All right, I come to the origin, the center, where that is, right? Go down to where the -1 is. Remember, x first, then y. There's that point right there, right? That's 0, comma, -1. Next, I have -1, comma, -4/3, right? So we're gonna come across on the x-axis to -1. -4/3 we know is gonna be between -1 and -2, right? So I'm gonna say somewhere like right here. Right? It's hard for me to say definitively where it is, but I know it's somewhere around there. And then last but not least, I have 3, comma 0, right? Come across the 3, right? That's it. Sorry, I had a little frozen section here. Come across to the 3 on the x-axis for 0. So this is 3, comma 0. And then after that, just connect the dots. Connect the dots. Not a computer, but I tried. And that's it. So as I said, you could pick whatever you want. You have my blessing. If it was me, I would pick the most simplest numbers possible, so I don't have to stress. But yeah.
What's the numbers that you think to make it this hard? So like you don't have to do all that extra.
So for me, well, 0 always will work. So definitely 0 is gonna be in everyone, right? If I can use the 1 or the 2, I would use 1 or 2, whatever, if I had a whole number as my slope, right? Now, if the slope was a fraction, I want to use the inverse of it, positive and negative, like kill 2 birds with 1 stone. Yeah. So that would be my strategy. Again, just suggestions. You can do whatever you like, as long as it works. Two, 24 minutes. Yikes. Okay. So next thing that I want to talk about, I see this in tutoring all the time, right? Graph vertical and horizontal lines, right? So some linear equations have only one variable. They may have just x or no y and no y, excuse me, or just y without an x. This changes how we make a table of values to get the points to plot. Let's consider the equation x is equal to -3. This equation has only one variable, x, right? The equation says that x is always equal to -3, so its value does not depend on y. No matter what is the value of y, the value of x is always -3 in this example, right? So let's take a look at that in terms of a table of values, right? So to make a table of values, write -3 in for all the x values in this example, right? Then choose any values for y, right? Since x does not depend on y, you can choose any number you like, but to fit the points on our coordinate graph, we'll use 1, 2, and 3 for the y coordinates, right? So we have x is -3 for all of them, but for y, we're gonna have 1, 2, 3. Put them together, right? As a pair, we have -3, comma 1, -3, comma 2, -3, comma 3, right? That's gonna lead us to be able to graph this, right? So let's take a look at the graph, right? So plot the points from the table and connect them with a straight line. Notice that we have graphed a vertical line, right? Vertical means going up and down, right? All the x values are -3, the y values are changing, and that's the vertical line, all right? Horizontal is just the opposite of that, right? It's just the opposite. Let's take a look. So what if the equation has y, but no x? Let's graph the equation y is equal to 4. This time, the y value is a constant. So in this equation, y does not depend on x. Fill in 4 for all the y's in this table right here, and then choose any value for x. We'll use 0, 2, and 4 for the x coordinates, right? So we have x is 0, y is 4, x is 2, y is 4, x is 4, y is 4, right? So as a pair, we have 0, comma 4, 2, comma 4, 4, comma 4. All right, let's take a look at that graph real quick. All right, in this figure, we have graphed a horizontal line that passes through the y-axis at 4, right? Horizontal means left to right, right? Horizon. And that's the horizontal line. So long story short, they're gonna tell you what it is, so you don't have to worry. Got you. So here's the same thing that I just said in words. Got you right now. So vertical and horizontal lines. A vertical line is the graph of an equation of the form x is equal to some number. Let me say that again. X is equal to some number, right? That's a vertical line. That's the vertical line. The line passes through the x-axis at whatever number it's equal to. A horizontal line is a graph of the equation, is a graph of an equation of the form y equals b. This line passes through the y-axis at whatever 0, comma b is. All right? Questions on that? All right. This is actually really, really simple compared to what we just did. Like really, really simple. Let me show you. So for this one, right? Let's say for A. Hold on, let me get a pen. I always make that mistake. Let's say for A, right? I have x is equal to 2, right? I'm gonna make a table of values. We have my X, we have my Y, right? So exactly, right? So everything is 2 for X. So 2, 2, 2. Right? And I could choose whatever I want for Y, right? You already know, -1, 0, 1. Right? Of course I'm gonna do that. After that, let's just make that graph right there, right? So we have 1, and then this is 2, and then I have 1 here. You already know 0, then that's -1, right? Vertical line going up and down, right? This is X is equal to 2. And you can, ooh, my fault. Like I said X, but I wrote something wrong. So then this one right here, if you want to plot the points, this is 2 comma -1. On the x-axis, this is 2 comma 0. And then down here, that's the 2 comma -1. I'm sorry, the top one is 2 comma +1. Excuse me. Sorry about that. Let me just write that a little bit higher. Okay. Questions on this? I'm literally just copying whatever they tell me. Go ahead. The labels, yeah. What? Good. So let's try B. Y is equal to -1. Awesome. Yeah, that posted. So for B, I'm still waiting for the third one to download. By the way, so for B, I have Y is equal to -1. Let me verify that because I got maybe, yep. Y is equal to -1, okay? Same game, right? I'm gonna make a table of values, just like so, right? You already know Y is -1, -1, -1. And then just make up some X values for me, right? What do y'all think? 3, 2, 1. That was making it hard. All right, fine. We'll do it. All right. So, boom, right? Our X values we're gonna have is 1, 2, 3. And my Y value is what? -1, right? So you could plot these points right here. So this first point right here, this is 1 comma -1. This is 2 comma -1. This is 3 comma -1. Horizontal line. And that's Y is equal to -1. Questions? Doesn't matter. But this is only for when we're doing vertical and horizontal lines. Well, the other section didn't really matter what x's we plugged in either. It's totally up to you, whatever you want. You guys try. While you're doing that, is 5. What was the other one? 4? X is 5. Yeah, that's good. That's good. Good. Awesome. Good job. So if y is -4, it's down here.
Who is X, Y?
The x and then y.
Oh, all right.
It's all good. The philosopher that came up with this, he used to do things like that all the time. Yeah. Confusing to read his book, but very interesting
It's
idea.
probably just because I gotta put Y here and label it more.
Got you. Yeah. Alright, I'm gonna let that finish. While we go over these, okay? So I have x is equal to 5, right? Same game as before. Let's make a table of values. I have my x, I have my y, right? X over here is what? 5, right? So I have 5, I have 5, I have 5. These are 5s, not s's. So y'all know. It doesn't matter which y's we're gonna choose. Give me 3. 0, 1, 2, okay? So I'm gonna have my graph over here, right? When x is 5, 1, 2, 3, 4, 5, right? So when x is 5, we have this point here, 0, I'm just gonna be 5 comma 0, excuse me. We have this point here. Pretend that that's 1, pretend that that's 2. Right? This is gonna be what? This is 5 comma 1 up here. 5 comma 2. Make my line. That's it. Questions? Awesome. Let's take a look at the other one. This is A, by the way. X is equal to 5. Let's look at B. Where this is Y is equal to -4. Right? Same game. I'm gonna make a table of values. I have my X, I have my Y. Right? So Y I know is what? -4. And what's X? Give me some X's. 0, 1, 2. Okay, not bad. So I'm gonna draw my graph like so, right? I'm going down to 1, 2, 3, 4 over here. Right? So this is the point 0 comma -4. Come across, this is 1. Oops. Hold on 1 second. 0, -4, good. And then 1 comma -4. And then 2 comma -4. And combine like, excuse me, combine like terms, just sorry. Connect the dots. And that's it. Y is equal to -4. Questions on this? Good? All right. Kinda, yeah. Pretty much. Oh, my fault. You want to make it smaller? Sorry about that. I apologize. There you go. Of course, you should label your axes, your axes. Don't copy my bad behavior.
It's so weird, like name for it, like the Y is horizontal. That they go with it.
Yeah, the Y is the vertical axis, but it measures horizontally. And the X is the horizontal axis, but it measures vertically. I don't know, it's just a notation that they came up with, mathematics. Yeah. All right, so since we all get that, all right, let's look at this. Hey, so I want to find X and Y intercepts. All right. Every linear equation can be represented by a unique line that shows all the solutions of the equation. We have seen that when graphing a line by plotting points, we can use any 3 solutions to graph. This means that two people graphing on the line might use different sets of 3 points. At first glance, their first lines might not appear to be the same since they would have different points labeled. But if all the work was done correctly, the lines should be exactly the same. One way to recognize that they are indeed the same line is to look at where the line crosses the x-axis and y-axis. These points are called intercepts of a line, right? Really, really important for Math 30. This is really, really important. Let's take a look. Intercepts of a line, right? So the points where a line crosses the x-axis and the y-axis are called intercepts of the line. So let's look at this example that we have here. Okay, so I'm looking at the one on the left, right? Let me just circle that. This one I'm looking at, right? Help me out. What's the x-axis here? The x-intercept, excuse me. 3 comma 0, right? So it's a point, right? This is my x-intercept, right? What's my y-intercept? Right? This is my y-intercept. And that's literally the answer. You just tell me what it is and boom, we're done, right? Let's look at the other one, right? Let me get orange real quick. All right, let's go. What's the x-intercept? Very good. What's the y-intercept? I'm impressed. Pretty good. All right. How about over here? Let's look at the one on the left. All right. What's the x-intercept? Very good. What's the y-intercept? All right. And this is our equation down here. X minus y is equal to 5. But anyway, how about this last graph? What's the x-intercept? Good. That's the x-intercept. What's the y-intercept? It's also the y-intercept. Very good. All right. Want y'all to see that. Let's talk about it a little bit more from like the table point of view. So first notice where each of these lines crosses the x-axis. Now, let's look at the points where these lines cross the y-axis, right? So we have figure A, which was the first one, this one over here, right? The line crosses at the x-axis at 3, so the ordered pair for this point is 3 comma 0. And then the line crosses the y-axis at 6, where our ordered pair is 0 comma 6, right? Long story short, right? Whenever I'm asking you like, what is the x-intercept? What is the y-intercept? These are your answers here, the pairs, right? It's a point. That's the intercept, right? Not at 6 or at 3, right? It's the points, right? So I want that tuple is what it's called, right? In the parentheses and the point, and so on and so forth, right? I feel like we get that. Figure B, figure C, figure D, right? I feel like Some of you might notice this pattern right here that forms. You all see that? The x-intercepts, right? They cross the x-axis when y equals 0, right? The y-intercepts, right, cross the y-axis when x equals 0, right? I don't know if you guys can see that pattern right there. So that being said, commentary, do you see a pattern? For each line, the y-coordinate of the point where the line crosses the x-axis is 0. The point where the line crosses the x-axis has the form a comma 0, and it's called the x-intercept of the line, right? Let's highlight that because that's really important. The x-intercept occurs when y is 0 in each line. The x-coordinate of the point where the line crosses the y-axis is 0. The point where the line crosses the y-axis has the form 0 comma b, and it's called the y-intercept of the line. The y-intercept occurs when x is 0. Any questions on this? Good? Okay.
Why you do 0?
Mm-hmm. Like my zeros. Boom, right? So here's a sauce right here, right? X-intercept and y-intercept of a line. The x-intercept is the point a comma 0, where the line crosses the x-axis. The y-intercept is the point 0 comma b, where the line crosses the y-axis. The x-intercept occurs when y is 0. See, y is 0 and some value for x. The y-intercept occurs when x is 0. So see, x is 0 and some value for y, all right? This is really important. That's why I keep repeating it. All right. Let's try this out. This is going to be a little bit small. So I'm going to try it out like this. What I want to do here is I want to find the x and the y intercepts, by the way. I'm going to try it out at this size. Let me know if it's too small for anybody, right? So I'm looking at A, for example. I want to know what is the y intercept, what is the x intercept. So somebody tell me what is the x intercept if you can see it. So I heard 0 and 4. So right here, 0 comma 4, right? No. 4 comma 0. Now we're talking, right? This is 4 comma 0. Remember, x goes first and then y. What is the y-intercept? 0 comma 2. Okay, so go to 0, go up. To 0 comma 2. Very good, very good. X-intercept, y-intercept. When you're graphing, you don't have to tell me that. I'm just doing this so that you guys can know, kind of thing. But anyway, let's look at B real quick, right? What is the x-intercept? What is the y-intercept? Very good. 2 comma 0. What about the y-intercept? 0. Okay, sounds good. 0 comma negative 6. Excellent, right? Just label that just for you guys. I'm sorry? It's always 0 because it's on the axis. The axis is our 0, right? So it crosses the x-axis when y is 0, crosses the y-axis when x is equal to 0. Always, always, always true. So are we good? Does this make sense? It does? Somebody here is shaking their head yes, and they're like, nah, I really don't get it. All right, let's try one more time. Hmm? Yeah, always, always, always. Let's try this one more time, though. One more time. Let's try another one. I'll make this one even bigger. All right, what's the the x intercept? What is the y intercept? All right, -5, 0. All right, and that's my y intercept, right? Oh, that's your x intercept. Good. All right. What's my y intercept? All right. 0, -5. That's my y intercept. So we good, no questions. All right. Nah, you know what? Just to make me feel good, y'all try. I want the x and the y intercept. While y'all doing that, let me just check how this is going over here. Feel like this is good. When y'all get a chance, just need one person to check, but multiple want to check this. Check out class 3 for me. I just want to know if the link is working. Works? All right, cool. Huh? No, no, no. So I'm posting the recordings, right? Yeah, but it's taking a minute to download. So like in between, like right now, that's when I'm doing that stuff. Yeah, it works. All right, cool. Gotcha. All right, that's probably gonna be another 30 minutes right now. So. Yippee. Yeah. Oh no, no, like that's me doing this upload right here. All right, let's get back to this. Sorry, help me out. What is the x-intercept? Okay, very good. Got 2, 0. X-intercept. What about the y-intercept? Very good. 0, -2. That's my y-intercept. Awesome, awesome, awesome. Questions on this? Good? All right. So recognizing the x-intercept occurs when y is 0 and the y-intercept occurs when x is 0 gives us a method to find the intercepts of a line from its equation. So to find the x-intercept, right, let y equal 0 and solve for x. To find the y-intercept, let x equal 0 and solve for y. Nah, 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 nah. Hold up, hold up. I know somebody didn't hear that. I don't know who, but I know somebody didn't hear that. I'm gonna say that one more time. To find the x-intercept, right, let y equal 0 and solve for x. To find the y-intercept, let x equal 0 and solve for y. All right? Let's try that out. Let's try that out. But you know what? I know someone here ain't hear me. So we're gonna say it one more time. One more time. Find the x and y intercept from the equation of a line. So use the equation of the line to find the x-intercept of the line. Let y equal 0 and solve for x. The y-intercept of the line, let x equal 0 and solve for y. All right? Now we good. Let's try this out. Let's try this out. I'm gonna pick the hardest question of them. All right? So I got 2x plus y is equal to 8, right? Let's say I'm looking for the x-intercept. You know what? I need a pen. Hold on. Let me get my pen real quick. All right. Let's say I'm looking for the x-intercept. Intercept is a big word. Just call it INT. All right? Mm-hmm. But wait, what am I letting equal to 0? Y, right? So basically, instead of having I have 2x right here, but instead of the y, I'm gonna plug in 0 for that. And that's gonna be equal to 8, right? So 2x is equal to 8. I'm gonna solve for x, so I'm gonna divide by 2. Well, I do to one side, I do to the other, so I have x is equal to 4, right? So what's my y-intercept? I mean, excuse me, my x-intercept, excuse me? Tell me in terms of a point, what is it?
4-0.
4 comma 0, very good. Right? What about my y-intercept? How do I get that? X is equal to 0, right? So this is going to become 2 times 0 plus y is equal to 8, right? 2 times 0, 0, right? Plus y equals 8. So I have finally y is equal to 8. But what's the answer? Tell me. 0 comma 8, right? This is your answer to the question. Any questions on that? Make sense? Go ahead.
You said when you got people like that, it's 0.
Mm-hmm. Right. So to find the x-intercept, you plug in 0 for y. To find the y-intercept, you plug in 0 for x. All right? Really important for Math 30. Go ahead. The 8 for the y-intercept. So I plugged in 0 for x over here. So instead of 2x plus y equals 8, I have 2 times 0 plus y equals 8. And then just simplifies down to y equals 8. Yeah. Then you just put it together in the plot. All right. So no questions on this? All right, you guys try. Go ahead. Mm-hmm. All right, you're welcome. So try it. While y'all do that, you do something else over here for 30 minutes. I feel like if I don't put like the details for the video, it might be like confusing. So that's what takes some time doing this. Wow, or something new. Okay, back to what we were doing. So I want the intercepts for this. X-intercepts, what do we have? 4, 0. Okay, I'll take that. What about my y-intercept? What do I have for that? All right. 0, 2. Any questions? We good? All right. Let's keep it moving. Huh? How? We plugged it in. So for the x-intercept, right? We plugged in 0 for y. And then we just had 3x is equal to 12, and then divide by 3. So we got x is equal to 4. Right? Remember, x equals 4 is not the answer. The tuple in parentheses is the answer. Right? And then for the last one, You had 3 times 0 plus y equals 12, and 3 times 0 you already know is 0, so this just became y equals 12. All right? That's it. So let's look at our next idea, what we're gonna do. I wanna graph the line using the intercepts, right? So to graph a linear equation by plotting points, we need to find 3 points whose coordinates are solutions to the equation. You can use the x and y intercepts as 2 of your 3 points. Find the intercepts and then find a third point to ensure accuracy. Make sure the points line up, then draw the line. This method is often the quickest way to graph the line, right? So basically what we're trying to say here, right? If we have to perform a graph of an equation or something, if we can find the two intercepts, the y and the x, we can use a straight edge, make that line and call it a day at that. You know, instead of choosing the 3 random numbers that we were choosing for x in the beginning. Right? It's just a smarter, easier way to do it. All right. So let's take a look. Try it out real quick. So let's say I have this equation right here, right? I want to graph negative x plus 2y is equal to 6, right? Very simply, what I could do is just find the intercepts, right? So tell me, what's the x-intercept here? If I'm finding the x-intercept, I'm plugging in what? 0 for y, right? So I have negative x plus 2 times 0 is equal to 6, right? Which is just going to be negative x is equal to 6. So what is it? What do I do after that? Very good. Divide both sides by -1. So I have x is equal to -6. So what's my x-intercept? -6 comma 0. Very good. Whoops. I already have enough. What's my y-intercept? How do I get that again? 0 for x. Very good. Plus 2y is equal to 6. Negative times 0 is just 0. So this is going to be what? 2y 6, right? We're going to divide by 2, so y is equal to 3. Very good, right? So what's my y-intercept? 0 comma 3. So what I'm telling you is, right, if I have a plot like so, right? And I know time is against us real quick, so I'm going to do this real quick. My y-intercept is 0 comma 3, right? So 0, just come up 1, 2, 3, right? And my x-intercept is -6 comma 0, so 1, 3, -1, -2, -3, -4, -5, -6. Just bear with me 1 second. Put this up. Let me get this point right here. So I have my my x-intercept over here, right? Which is -6 comma 0. I have my y-intercept over here, which is 0 comma 3, right? From those 2 points, I could find a straight edge and just graph these two just like that. Right? And that's my whole line right there. Right? Oh, yep. Let me get one more. Hold on. That looks good. So we find the two intercepts, we plot them, connect the dots. That's it. And I feel like it's good enough for you guys to do your homework, but let me just give you a little bit of notes real quick, and then y'all can call it at that. Huh? I'm sorry. 1 second, you guys. 1 second. Good? Got it? You're welcome. All right, real quick. I just want to put some words to what we just discussed. Bam. So how to graph a linear equation using the intercepts, right? This is just how to do it. Step 1, find the x and y intercepts of the line. Let y equals 0 and solve for x. Let x equals 0, solve for y. Step 2, find a third solution to the equation. Optional, your choice, right? Step 3, plot the 3 points, connect the dots to make the line, and then that's it. All right? So basically, it's the same lesson as before. It's just that I'm showing you a more strategic way of doing it, right? Using the intercepts. Okay. And I guess that's it. Oh, got to do attendance. Can I get a piece of paper, please? Somebody, pretty please. Thank you. Appreciate y'all. Just make sure I didn't leave anything like super important out. Yeah, y'all should be good for y'all homework. Sure. Is anybody still copying? Can I take it down?